So I'd just like to say welcome to our final NAC Ask Me Anything of the fall 2023 semester. My name is Susan Bogus, and I am an NAC member and interim chair and AGC endowed chair professor of construction engineering management at the University of New Mexico. The theme for our Ask Me Anything sessions this semester is the implementation of new technology in design and construction. This is a great opportunity to ask questions about the use of AI, robotics, modularization, digital twins, and other technologies being employed, and also to get career advice from these very successful professionals. The National Academy of Construction was established in 1999 to recognize our industry leaders. An important purpose of the Academy is to share the collective knowledge and experience of our members to improve the industry. We have established the NAC Ask Me Anything to help transfer knowledge of our members to our next generation of construction leaders with this webinar, providing a means to link past and present participants in the construction industry. Our Ask Me Anything sponsors this year are the University of Florida Rinker School of Construction, Arizona State University, Del E. Webb School of Construction, and the University of Colorado at Boulder Construction Engineering and Management. The format for the Ask Me Anything is simple. Our speakers will make a short presentation about a topic and their perspective on the industry, followed by time to answer your questions. If you have not already, please email your questions to nacama@austin.utexas.edu. One student will win a $500 scholarship, which we will announce at the end of this event. Now let me introduce our speaker for today. Professor Lucio Soibelman is the Fred Champion Estate Chair in Engineering Professor at the University of Southern California. He obtained his BS and MS degrees from UFRGS in Brazil and worked as a construction manager for 10 years before obtaining his PhD in civil engineering systems from MIT. During the last 25 years, as a professor at the University of Illinois, Carnegie Mellon University, and now at USC, he has focused his research on advanced data acquisition, management, visualization, and mining for construction and operations of advanced infrastructure systems. He has published over 250 books, book chapters, journal papers, and conference articles, and performed research with funding from NSF, NASA, DOE, the U.S. Army, and NIST, among many other funding agencies. He is the former chief editor of the American Society of Civil Engineers Computing and Civil Engineering Journal. He has been honored many times, including the ASCE Computing and Civil Engineering Award, the Richard R. Torrens Award, the Construction Institute Construction Management Award, and the ASCE Purify Construction Research Award. He is an ASCE Fellow, an ASCE Distinguished Member, was a Distinguished 1000 Talent Professor at Tsinghua University in Beijing, China, from 2017 to 2019, and is a current member of the advisory board for the Contour Craft Corporation, a developer and manufacturer of large-scale 3D printing. So please join me in welcoming Professor Lucio Soibelman to tonight's Ask Me Anything.
Thank you, Susan. Thank you for inviting me. It's a pleasure to be here. Hello, everyone. So what I'm going to do, I'm going to share a small number of slides just to start the discussion about what I've been doing and my interest in related to AI in construction. So let me share here and let me go here. So what I want to talk and discuss, and I think that it's going to be related to many of the questions that you are going to present to me, is that we are in the first time we are leaving what is called inflection point. Okay, we have machines being developed by hundreds of years, industrial revolution, robotics, that are replacing our muscles. Okay, so we always replace the muscles, but we still had safe was what we call the knowledge economy. Okay, This knowledge economy, it's why we have universities. Okay, it's where we teach students to do knowledge jobs like being engineer, structural engineer, construction management, things that computers could not do. This is changing today, okay? Not just by having smart computers, but a lot of power in the computers. You are seeing the driverless cars, much more advanced robotics. You have what I call artificial eyes, artificial ears, artificial hands, and all these being changing and allowing us to do amazing things. A lot of jobs are changing. If you think about the interpretation of medical images, lawyers searching for jurisprudence, finance jobs, and what I'm saying is that many jobs are about to disappear. But I don't want to get you scared. I want to show that a lot of jobs are going to be created. So I think that this is why I call this the inflection point, that you are the generation that are going to be delivering the work in those new jobs. And many of those jobs will be related to construction, to civil engineering. If you think about, I don't believe that you're going to be doing scheduling estimates the way that you do today, 10 years from now. I strongly believe that you're going to be using data-driven approaches to solve those types of problems. So in the past, we had a very data-poor industry. The construction was extremely data-poor. You always try to use experience. You had, to be a good construction manager, you need to have many years of experience. Because you didn't have data, you have to use the experience, make mistakes to learn with your mistakes until you get to be a good engineer. Today, you are facing an explosive growth in generating and collecting data. So we are now starving for knowledge. We have the data, but we are drowning in this data. So my research has been always to organize this data, like linking documents to models. For example, where you have a 3D model, you get a 2D representation of 3D model, you click in an object, electric fixture, and voila, you retrieve every document that talk about that object. How you organize those things, images, same thing. You have thousands of images with many objects on the images. Can you double click in any element like a wall and retrieve every picture that shows that wall? So this is a lot of organizing this data that you are drowning, and I have a lot of interest on that. We are creating advanced 3D models using laser scanners and drones and cameras, photogrammetry, but again, we are drowning on those models. They are not really objects. They are cloud of points. So how you transform those points in objects that you can, for example, link to beam. So this is research that I did to the Army, extracting from war zones and bases, extracting a lot of information from drones, then creating kinetics and other simulation where you can train soldiers. Who is going to develop those systems? And the reality is that this professional today doesn't exist. The civil engineer that understands the physical world, it's not prepared to move to that digital representation of the physical world. And the computer scientists understand the digital world, but they don't understand the physical world. That bridge has to be done. Those are the jobs that you're going to create. This is the work for the Army that you could create in real time during war, create a vision of a sniper and trying to show to soldiers where they could not move to because they will be hit by a bullet from the sniper. A lot of robotics happening today. They are not completely intelligent yet. They are not completely autonomous. This is a research that we developed here at USC with my colleague Burcin, where you use virtual reality to train robotics and remote operated equipment. You are moving to teleoperation of those equipment. I strongly believe that the robotics today, you're talking a lot about very autonomous robots in construction. I believe that this is going to be a thing being done during time, and how this is going to develop from not using those robots to have those completely autonomous. So you have a lot of work on that. lot of interested in intelligent construction with 3D printing, this equipment that we bought for our lab from Contourcraft. And again, at the limit, I'm doing research with NASA for construction in the moon. They have to do a lot of earth work. That's not earth work, it's moon work, to move soils, to create landing pads for the Artemis project, a lot of 3D printing the moon. They have very interesting equipment, excavation equipment at NASA, and you are developing all the soil, the regolith, that it's the moon soil transportation systems. So the idea is that there is a whole new set of jobs, but we don't have the professionals to do it. You are the generation that are going to be able to solve those problems, and you should be very, very excited. Not afraid of AI replacing your job, but seeing the jobs that AI is going to open. So just to give some context, and I'm going to stop sharing, and now I'm ready for your questions. Susan, you're mute.
Thank you. All right. All right, here we go. You talked about lots of data, so let's talk about that. Here's one question. The volume of information generated in construction and operations can be overwhelming. How do your frameworks and algorithms address the challenge of information overload, ensuring that relevant insights are extracted from the vast amount of data available?
So that's a very good question. It's not just a question of data, but the problem is what type of data we're talking about. As I said before, you have text documents, that it's a complete different document that if you have a spreadsheet, that you have when you have cameras or drones acquiring data, or when you have sensors and other types of data acquisition on site. So we will need not to be just able to crunch the data, but be able to crunch different types of data. And for every type of data, there is a different type of technologies that we have to use. I do believe that the first step is just to organize the data. I love the idea of BIM. You have the building, that's the physical. You have the M, that it's the model, that it's the digital. We talk a lot about digital twins, and we can come back to those terms later. But then the I in the middle, that's the information. That's the big difference from the 3D model, that's the digital, to the physical. What links everything together is the I. And I do think that the first step is to organize that I, as I showed in my introduction, organizing text, organizing images, linking information to objects, extracting objects from scan to BIM, a lot of work to do on that, to be able to do the analysis of if the project's behind schedule, if the objects are in the right position, with the right quality, in the right materials. All these you would be able to do automatically if you learn how to deal with this large amount of data. It's a fun world, a lot of interesting things happening, a lot of new softwares being developed by some of our colleagues and professors, have some startups. It's an exciting time, but again, there is a need to learn a lot of statistics, programming, and a lot of machine learning tools to be able to deal with all this type of data.
All right, great. So maybe that ties into this next question, which is two-part. So one is, what do you find to be the biggest challenges when it comes to implementing technology in designing construction? And what sort of supplemental education do you recommend for students looking towards the future?
That's exactly what I'm trying to say. So the question answers my quests that I'm trying to explain. Let's go to a simple example, okay? So let's think about a smart bridge, okay? What's a smart bridge? It's a bridge that has a lot of sensors, and it creates simulations of its behavior from data coming from those sensors. So you have information about the load that is being driven on top of the bridge. You have information about cracks that are forming. You have information about some movements in some joints in the bridge. And then you need to have a very good structural model of that bridge to use that data to predict what's going on, predicting what's going on with the bridge, and if the bridge is going to collapse, if the bridge should be closed, and all those types of things. So now try to understand what is happening today. You have the structural engineer that understand about the structures, understand about the behavior, but doesn't understand very well about the sensors and doesn't understand very well about how to deal with that data to generate those models. On the other hand, you have the computer scientist, knows a lot about machine learning, knows a lot about the data and managing the data, but doesn't understand about the structural behavior of the bridge. So they won't be able to select where to put the sensors. How many sensors? What type of sensors? You really need to understand the structural behavior of the bridge to understand which data is the input for you to run your simulation models. So today you have those two professionals that cannot solve the problem. There is a communication issue, and those systems are, you can have today bridges with sensors collapsing because the sensor is in the wrong place and it's giving the wrong information. It's the wrong sensor and every other problems related to that. So what you need is, other question that I have is that what it's easier to train the structural engineer into advanced machine learning and AI, or to train the AI person into structural engineering. I do think that it's easier to train a structural engineer to learn AI than a computer scientist to learn all structural engineering. But I do think that there is a need to have a professional in the middle that can communicate with both, understand the structural behavior and understand data, and then can tell both and discuss with both and design those systems, even if it's not going to be the implementer. Doesn't need to be the code, the writing the code. This could be done by a computer scientist. It's not going to be the one developing the structural models, but they can design and extract what is needed from both types of professionals. So I'm not sure if this is going to be a new professional or the civil engineering it's going to be able to add that into their curriculum. But this new professional is needed. And what they need to learn a lot of statistics. They need to learn a lot of signal processing. They need to learn a lot about hardware and sensing. They need to learn a lot about machine learning and other AI tools. So there is a lot, and to be able to learn all those things, they need to know programming, they need to know Python, they need to know several other tools to allow them to develop those systems, or at least specify those systems for people to build to them. So, and this is the inflection point that you are talking. A lot of departments of civil environmental engineering are discussing this, understanding that you have a tight 4 years undergrad curriculum, so we cannot keep adding things to the curriculum without dropping things in the curriculum. So this is a long discussion that everyone has, and it's not an easy one. But I do think that students can learn a lot of those things by themselves, learn how to learn, the lifelong learning, adding those expertise and this knowledge in those domains by themselves, even if they're not having classes.
Right, great, thanks. So once again, this is great. All these, your answers are like kind of guiding right into these questions here that they're very related. And so you talked about the need for like AI and the example and you know, the interaction between, say, the structural engineers and the maybe computer scientists. And the example you gave was on the bridges and sensing. So here's a question that talks about the use of AI on more traditional project management type tasks like estimating and stuff like that. Where do you see the vision or AI being used in more project management or construction management type situations?
So let's think, that's a good example, estimating or scheduling, okay? How you do it today, okay? Estimating, you use something called RS means, okay? That's a table, that's an average, okay? We go and you get, okay, 1 square feet of, you measure, you go in the blueprints and you measure a wall. There is 10 square feet. And then you go to the cost composition in RS means and you look, a square feet of brick wall takes X hours of bricklayer, Y hours of helper, Z numbers of bricks, okay? Y more quantities, cubic meters of mortar. So you have all those compositions and you multiply, okay? But my question is it always the same for every type of wall? It's the same number that you have from a wall in the first floor or a wall in the 50th floor? It's the same number for a wall in the summer in Texas or in winter in Massachusetts? Okay, using those compositions is just average, and then comes the experience of long time estimators. Oh, this is an average number. This is going to be winter in Massachusetts. You have to have multiply that by 2 because I'm expecting snow. I'm expecting to be too cold, and productivity go down. It's obvious that you cannot continue doing things this way. You have to have, companies need to have very large databases that you're going to have features that are going to represent your wall that you are building, that it's going to find similar walls. It's going to say, okay, this wall, it's going to be in the 50th floor in the cold weather region in the East Coast, okay, during January. So the database is going to use AI and machine learning, and it's going to tell you this is the number, that it's different than the number for Texas in the summer. So we are going to have to stop using those averages and using large databases. The problem is that companies need to start building those databases, and many are. Many large companies are already using databases, are not using averages. Same thing for scheduling. So all those things that you have data in productivity, construction materials waste, things that you can do now today that was difficult before. How you measure inventory of sand in a construction site? Okay, you have a pile of sand, around 10 cubic meters. Okay, now you can use a drone. You can calculate computer vision, and you can calculate the volume from that pile. That it's a very strange shaped pile, and you can come with very perfect numbers of volume from those things. So AI is coming in everything that you are already. You have software that you can fly drones and extract objects and compare the 4D from BIM with the as-built and find if the project is ahead or behind schedule. And more important, not just getting a number in the time. You can get a prediction. You can say that the project is not behind schedule, but 5 days ago it was ahead of schedule, 3 days ahead schedule, then 2 days ahead schedule, 1 day ahead schedule. You can predict that the project is going to be behind schedule 2 days from now, even if it's not behind schedule. So you can do a lot of data analytics if you're acquiring the data, extracting knowledge from this data, and it's infinite opportunities. So each company is finding different things because they see competitive advantage in different uses of their data.
Okay. So how do you think these advancements in technologies can benefit or be used by smaller companies who might not have the capital or resources of larger companies?
I think that this, there is the first movers, that there are large companies that are making investments, but then there is softwares that are coming, and because of the investment of the largest companies. So you have a software from one of our colleagues, Money, from University of Illinois, Urbana-Champaign. He has a software that you fly drones, and it's now owned by Oracle. So those softwares would be available, and they would do a lot of intelligence, and smaller companies would be able to buy, not develop those systems, but buy them because they would be available. I think that it's the same thing that happened with BIM. BIM started with a small number of companies until it got so traditional, and better softwares and Solibri and other types of easier softwares to use came available, and then smaller companies start using it too.
Okay. So several students asked questions related to sustainability. So I'll try to see if I can summarize this, but one question asked, how is the industry preparing to safeguard and adapt both new and existing infrastructure projects to be more resilient and get against environmental changes, and how can AI and technology, be used to improve sustainability?
Different ways, okay? This research that I've been interested to. So in sustainability, you can develop tools. I have patents with previous students that you developed sensors that install at home and can help you kind of transform your electricity bill like a supermarket bill. This is by using AI. You have a sensor that clips in the main feed in the house. It sees the spikes in energy consumption, recognizes signature of which appliance is consuming, so it can give you an electricity bill that looks like in real time you are spending X kilowatts in the refrigerator, Y in air conditioning, Z watching TV. So all those types of devices that would be available by dealing with data will allow us to make better decisions of how you interact. So this is a whole area of human building interactions that would allow us to interact with the buildings and receive information from a smart building that would tell us how to be more efficient and more sustainable. There are a lot of research that I did with other PhD students that we were able to replace the digital camera on drones to infrared cameras and map the envelopes of building for leaking points that are losing energy to retrofit buildings to make it more energy efficient. So those are a lot of tools that would be possible. We have research that we look into the cost of infrastructure failure for extreme events, from hurricanes and other types of extreme events, looking at what happened when a bridge collapsed. Again, data-driven approaches that we could predict not just the cost of replacing the bridge, but the cost of the impact of not having the bridge for 2 years while you are rebuilding it. What happened that people have to drive more miles, more fuel consumption. People would not be able to reach Walmart on the other side of the bridge, so that Walmart would close, people would lose jobs. So really interfacing transportation models with economic models driven by data coming, we got it in LA, data coming from 10 million commuters a day. Okay, so there is an organization in LA called SCAC that tracks 10 million commuters every day. So data is available and allows us to do very different types of analysis with the objective of sustainability, of extreme events, climate models. All this is getting better, and because we are starting to have better data.
Okay. So several students ask questions about sort of get out your crystal ball and predict what you see coming in the future. So let's see what you say. And so one of them is, what is the one piece of new technology that you see becoming mainstream for years to come?
I do think that robotics it's going to come to construction, okay, in several different ways. I do think that the first, it's a little bit more remote operated equipment in areas that are dangerous. Safety is still a big problem in construction. It's a huge problem. I cannot believe that we send workers with a pneumatic hammer to break concrete, allowing things to fall on top of them. It's very easy to send a very small robot that would, what you call demolition robots, that would be still operated, not completely autonomous, operated by a human, but in a safe distance, not pushing the person into that dangerous zone. Same thing, I cannot believe that still send workers in the 50th floor in a scaffold to to paint or to clean a window. Okay, so we have to rethink all those jobs that are dangerous, and we have to find equipment that first is start by remote operating it. Can be with eyesight, so with the operator seeing the equipment on the construction site, but not at the area that's the dangerous area. Then the next step, I do believe that you remove workers from the construction site, allowing them to teleoperate those equipment from distance. If you really can do this, and this is my interest with the research with NASA, we have to teleoperate the equipment at the moon. So if you solve the problem to the moon, we are going to learn a lot about how to do it here on Earth. But this teleoperation would allow us to hire more women in construction, to hire disabled people in construction, to have older workers that have back pain that cannot work on the site, and to have a lot of knowledge construction, but you are retiring them. If you can provide them a safe and comfortable place that they can work, they can keep their knowledge and still support our industry. And then with all these equipment, start getting more autonomy and start doing things more independently and being more intelligent. This is more difficult in construction than other industries. So why? Because you have a lot of human interacting with those robots. Majority of the automobile assembly line, you separate the humans. When you have a station that has a robot, they cage it and they don't let humans around. And then the next stage, if it's a human welding something or doing something, it's a human, but not a robot. And it goes from station to station, some with robots, some with humans. In construction, you are going always to have a robot working, a demolition robot, and a carpenter walking by. So we cannot isolate. So humans are going to be interacting with those equipment. And we have a lot of research to do, and we are doing research in those areas. But I do think that this is one of the first things that's going to happen. I do think that the beam is going to get more intelligent. Okay, beam it's going to start moving to my you have more intelligence within the beam, and then this would move to what we discussed. I discussed at the beginning. That's the digital twins. What's the difference from 3D model to beam and to digital twins? It's a long discussion, but for me, the digital twin, it's when you have communication in both directions. A good example would be a smart thermostat. The digital twin doesn't need to be for the whole building, could be for systems. You have a sensor in the building that has the thermostat. You have the physical building that has a temperature. The thermostat gets that temperature. The thermostat is connected to a computer that simulates the change in temperature and the comfort of users, and predicts how uncomfortable the building is going to be 5 minutes from now, makes a decision to optimize energy, to optimize comfort, change the settings of the air conditioning. So it's the digital changing the physical and the physical changing the digital. And this is, for me, the definition of digital twins. Just having a very good representation of the as-built, for me, it's not a digital twin. It's a very good, accurate 3D model. Okay, so you have the 3D models that represents the digital representing the physical. For me, is still a 3D model. When you start adding information and intelligence, linking things, doing clash detections, doing actions with that information, it's BIM. And then when you move forward, when you have one affecting the other, you have the digital twin. I think that this is a natural progression that's going to happen. And this is, for me, a no-brainer. This is something that you're going to be facing without doubt in the next few years.
Okay, great. So you just answered my next question. So let me go on to the next question after that. So this one has to do about the future of some of the maybe hardware devices like VR, AR devices that we're starting to see out, commercial players like Apple and Meta coming out. Where do you see the future of those on construction sites? And are there issues you foresee with maybe safety or anything like that?
I think that first they would be used for training, as we are already doing. Okay, I think that a lot of training can be done in virtual reality and could be better than training in the real world. We already tested that. The slides that I present of research that I did with Burcin at the virtual reality training for that demolition robot, we realized that like a flight simulator, okay, you can train the pilot to land without tires. Okay, they crash land 10 times until they learn how to land. We cannot do it in the real plane. Remove the tires, the pilot dies, next pilot. So you cannot do those types of things. You really can push the envelope in the training, expose them to situations that are dangerous. They can kill someone in the virtual world. It's very easy to do it. It's a video game. You have a lot of blood in video games, so you can simulate a lot of those things, and the workers being exposed to normally you can train them just with the right examples. In the virtual world, you can even show them what happened when they do a mistake, when they do something wrong. I think that from that, we are going to see the evolution of those technologies coming to sight with what you call X-ray vision, okay? Those mixed realities where you can see the piping behind the wall. You can superimpose the digital into what you're seeing physically. You can do a lot of control for counting rebars and all those types of things. I think that it's a no-brainer. This is coming, and safety, yes, you have to look about the safety. People are going to have part of their vision obstructed by those devices. It's not going to work. So you have to understand the impact on safety and ergonomics and all those types of things that's going to start changing. And that another huge set of research. So if you really want to join us and other colleagues, we are doing research to solve those problems. You don't have the answers, and this is why academics and research exist. We have many questions related to those things.
Great. So with our last few questions, I'm going to have a few students that ask sort of career-related questions. And you talked a lot about technology, and I think everyone has a fear of technology replacing jobs. So this question deals with how does the implementation of new technology impact one's ability to obtain a job in this field?
I don't think that anything it's an impediment for getting a job. There are jobs, okay? There is a need in this area. Companies are always calling us looking for traditional construction engineers or very advanced students that we are developing with our advanced masters in robotics and those technologies that they call the agents of change. So I think that there is a job for everyone. Okay? The problem is not getting a job. I think that the question is a little bit different. It's how not to get obsolete. Okay, so if you get a job today because you know Primavera, you know how to do scheduling, and you learn it Revit, and you know Beam, but 5 years from now it's Boom, and then after it's BAM. How are you going to cope with that technology that is changing so fast? So my recommendation is lifelong learning. You have to learn how to learn. You have to keep yourself challenged and learning in place of watching Netflix, using that time every evening to study and to get a little bit better. And this should be fun, should be as fun as watching Netflix. So learning and moving with the technology. So I don't think that the question is getting the job. My question is keeping your job. This is what you should always think about. I do think that all of you are going to get your jobs. I don't think that we have problem finding positions to any type of civil engineer and construction manager today. There is, all students are getting multiple offers. But I can guarantee you, if you don't move, you will be fired 10 years from now because you end up being obsolete. And then your employer would come to the department, to me and my colleagues, hiring the new generation to deal with the new changes that are going to happen in our industry.
All right. So here's a question. As a student, it can seem daunting looking at different career paths and the career paths of leaders in global construction firms. Do you have any advice on where a student should start if they aspire to follow a similar career path and eventually become a global leader in civil engineering and construction?
Any path. I am a good example. I did work in the industry for 10 years and wasn't happy, and went back, got my PhD, and got to be an academic and doing research that I like more. So you should never be afraid of making mistakes, and should never be afraid of changing if you think that you want to go in another direction. So life, it's long. You have a long time to learn and to change and to find a new niche and to re-educate yourself and educate alone or go back to school. So no path, it's a wrong path. The only wrong path, it's the path that you are doing and you are unhappy. As my example, I can talk about how I arrived to that conclusion. I came from what I call a very dysfunctional family. My dad is a civil engineer. My mom was an architect and civil engineer. I have 3 sisters that are engineers, married to engineers. So I never had trips to Disneyland as a kid. Trips for me was to visit the construction of a bridge, a new building, or historical, or going to Paris to see the solar system. Not to see Champs-Élysées. You go underground to see the solar system. So it was fun. I always loved engineering. But then when I started working first in my father's company and then with my own company in the construction, I was someone that I'm always a why person. I would go to a construction site and I would ask why the wheelbarrow has 1 wheel. And then I would get crazy designing wheelbarrows and the whole project behind schedule because I had a new curiosity in life. I realized that the life in construction was you keep moving, you are behind schedule, you deliver, don't think too much because you can delay a project, you don't have a lot of opportunities to change the process because could have consequences in the schedule and the budget. So this would frustrate me. And I came back to academia, got my PhD, and my whole life now it's asking those questions. Why a wheelbarrow has 1 wheel? And then I can write a proposal and get money and work 3 years trying to answer that question. So I'm very happy in that path. I love what I do. But you can start in one direction and realize that you want to go, but never keep in the direction that makes you unhappy. This is a recipe for disaster. Find your path, and if you find in the first try, wonderful. But there is no problem of moving and having different tries until you find your passion.
Well, thank you. Great career advice for all of us here. And so that was our last question. We do have a winner of our students who submitted questions. And our winner today is Kenny Padula from Wentworth Institute of Technology. So congratulations, Kenny. You have won a scholarship from NAC. And so at this time, I'd like to thank our speaker, Lucio Soibelman, for the great insights you provided us. And also, I'd like to say a special thank to our sponsors, the University of Florida Rinker School of Construction, Arizona State University, Delhi Webb School of Construction, and the University of Colorado at Boulder Construction Engineering and Management. So this is the last Ask Me Anything for this fall semester, and we look forward to seeing you at our next webinar series in the spring. Thank you very much.
And my email, it's very easy to find. If you go to USC and look for Lucio Soibelman, if you have any questions, please don't hesitate in contacting me. And I'm looking forward for good master's students and PhD students. So we would love to be in touch with you. Thank you very much.